we're given just a single point on a curve, y equals f of x. So it's minus 2, minus 5. But in fact, that's all we need when we're applying some transformations to it. Minus 2, minus 5 will be, say, down here. So what happens when we have a function and then we transform it to f of x plus 2? It's actually a translation by 2 in the y direction. So essentially it's just going to move up by 2, but we say translation instead. And so for the x value is going to stay the same as minus 2, but then we're going to add 2 to the y value, giving us minus 3, and that's our first answer. Next up, the modulus function. So the modulus function, if a function is positive, it does nothing, or actually if it's 0 as well. But if it's negative, then it makes the function positive. Okay, so if it's minus 5 down here, then it's going to bring it up to here at 5. So again, the x-coordinate stays the same. That does not become 2. It stays as minus 2. You get minus 2, 5. Finally, we've got successive transformations, a whole variety of them. Okay, let's think about what's going on here. We've got our points, and I mean, the order is somewhat important, but let's deal with the x first. So I'm going to deal with f of x minus 2 is actually a translation by 2 in the x direction. So we're going to go to here, and I might just keep track of it now. So I've got minus 2 minus 5. After the x translation, it will be 0 minus 5. Then I'm going to multiply by 3. That's going to be a stretch. So that should be a minus there. So a stretch by factor 3 will actually give me 0 minus 15. Again, the x value stays the same because it's a stretch in y. And then finally, we're going to add 2, which is a bit like what we had up here. We're going to add 2 to the y value, which is going to leave us with 0 minus 13.